All right, so we got to here. We described two ways of explaining multiplying polynomials using like your grade 3 model for multiplication, right? When Mrs. Bad Crumble drew a picture of 3 apples, and then she drew a picture of 3 apples, then she drew a picture of 3 apples to explain what 3 times 3 was, right? You all remember that. If you don't remember that, it's no big deal, but you all remember that. That's what was happening on the left, right here. Right, on the left, right here. On the left here, that is what I was doing. That's the Mrs. Bad Crumble move, right? Because that was x plus 1, and we wrote it 5 times. Now, to make algebra tiles useful in helping us do something in future math, we have to set it up in a rectangle like this. Okay? On these rectangles, the factors are on the sides, and the product is in the middle. And if you're thinking about this like a rectangle, of course, that is the width, that is the length, and that is the area. Because length times width is area. Right? Now, for a multiplication standpoint, to multiply polynomials, this is as far as this goes. Okay? You can go one little step further, which I'm about to show you in a sec. Do you need to close the blinds, Vanessa? Do you need to close them further? Please do. From a multiplication standpoint, we're done with this. You might have to pull them out a little to come over my collection of mugs. Whichever way makes it go down, Vanessa. There's only 2 options. Try one. If it doesn't work, go the other way. For a multiplication standpoint, this is the end of it. This is all it can do for us. We will use it again when we go to what is called factoring, which I was talking about yesterday. We'll come back and show you this again. But just like now, when we factor, there's a way to do it algebraically. And just like now, there's a way to do this algebraically. You guys, I was already joking about this yesterday. You've already seen it. It's called the distributive property, which I have right here. This, for some reason, everybody can do it when it's one thing. And by one thing, I mean this. If it looks like this, ax plus y, everybody understands that it is ax plus ay. Everybody can do that. They can do it in their sleep. You already have been doing that this year with exponents, right? The problem is sometimes it gets more complicated than that. Imagine that, math getting more complicated. But it's not more complicated because it's the exact same thing. For example, if I were to give you a times x plus y plus z, what would it be? Ax plus ay plus az. What if I added another term in there? What would it be? Ax plus ay plus az plus a lightning bolt. The a just multiplies all the way through, right? That's all it is. It doesn't matter how many things are there. You just do the same thing over and over and over and over again, like every other thing we do in math. What if it was this? Actually, I'll come back to that. Everybody's happy? Everybody understands the distributive property? Yeah. Great. So now, let's do this. I want it as a picture from like grade 3, and I want it as algebra from like grade 10. So, grade 3, what are the factors here? What is the first thing that is multiplying? X. And what is the other thing? 2x minus 4. Because this is saying x times this. Brackets group this together, yes? If we know what x is, isn't this whole thing just one single number? Yeah, because that's what brackets do. They group stuff together. It doesn't matter how big I make this. If you know what the letters are, it's just one number. So if the factors are x and 2x minus 4, then we have to put them on the outside of our rectangle. X is that. 2x means I got to draw 2 of them. And minus 4 means I got to draw 4 of the little guys. And then all we do is what you see. This x is starting right here, yes? Everyone agrees? But it is multiplying the width of that x. So I get this big X. Well, if it's x on this side and x on this side, what is this? X squared. And then it happens again. And then that x is coming in here, but it's only one wide. But what wins, negative or positive? Negative, just like in real life. And now my answer lives in here. And all you have to do is count. 2x squared. Technically, it's plus negative 4x, right? Because subtraction doesn't exist. It's adding negatives. But math guys are too lazy to write that, so what do we write? 2x squared minus 4x. Okay? Everybody good? And of course, in algebra, x, 2x minus 4, it's just like what we did up here. That's the a, that's the x. So a multiplies by that. Just like in exponents. 2 times 1x is 2. X times x is x squared. Minus x times 4 is 4x. And you see we have the exact same answers. And it never gets more difficult. It just gets more complex. Okay? So you all try this one. I'm going to go in blue over here with the factors. I'm going to go in red over here with the algebra. Okay. Everybody is good? Okay. Turn the page over. 121. This is slightly different. It's a binomial and a binomial. But even though it looks different, does it change? What math is happening right there? Multiply, which means this is a factor, isn't it? And this is a second factor, isn't it? Where do the factors live? On the outside of the rectangle. So we draw a rectangle. One factor goes here, x plus 3. One factor goes here, x plus 2. And then we fill it in. And that gives us our answer when we count it up. 1x squared. How many x's? 5x plus 1, 2, 3, 4, 5, 6. Done. Right? There are no like terms there. X squared and x are not the same, as you can see from our drawing. What about the original equation? I know. That's what we're about to discuss. X plus 3, x plus 2. Now, if there was no 3 there, how would you do that? X squared. And then plus 2x. Everybody see that? Okay. Now, what if there was no x there? What would you do with that? Distribute. 3x. Hey, I've already got some x's. I'm going to put them together because they're like terms. 3 times 2 is 6. And then I can add them up. X squared plus 2 plus 3, 5x plus 6. Right? It's exactly what we did before, except I had to do it twice, which leads us to another one of those little shortcuts that math teachers like to give you that I don't like. Many of you have seen this already. Some of you, or possibly many of you, haven't. You have seen this acronym, FOIL. And FOIL stands for first, outside, inside, last. Now, I don't like this because FOIL only works for x plus y and a plus b. It only works for binomial times binomial. So people get stumbly because you guys don't learn what's actually happening. You learn shortcuts. So when I write FOIL, everybody has no problem with it. And everybody, oh, first, outside, inside, last, I got it, I'm all up in it. Until I give you this question. X squared plus 3x plus 9 times x squared plus 4x minus 7. Now all of a sudden FOIL doesn't work. Because there is no first, outside, inside, last. There's 3 things. So I don't like to spend a lot of time on FOIL, but I cannot convince my math compatriots to stop calling it FOIL. I can't. I've tried for years. They won't. So I'm forced to deal with it. And then I'm forced to tell you, don't call it that, or you will get trapped in the same shortcut trap that you have been trapped in since the 3rd grade when they started teaching you math. Okay? What it means, of course, x plus 2, x plus 3 is first. You take the first term and you multiply it by the first term, and you get x squared. Then you take the outside terms and you multiply them by each other, and you get 3x. Then you take the inside terms and you multiply them by each other, and you get 2x. Now, I stack these up so my like terms are right attached to each other. I'm going to show you what you might have been shown before, and I'm going to tell you why I don't like that. Okay? And then last is the green arrow, and that is plus 6, since 6 has no like term. And then I add it up. x squared plus 5x plus 6. Now, how many of you have seen FOIL before? Okay. How many of you had a teacher that stacked FOIL up like this? Okay. My bet is your previous teachers said this. Plus 3x plus 2x plus 6. Wrote it all in one line. No problem. 3 plus 2, easy peasy, it's 5. But I know from experience that dealing with you people, if it was this, for example, minus 2 minus 3, x squared minus 3x minus 2x plus 6. Half of you aren't able to do that in your head, and you think you are. Half of you will tell me that answer wrongly. Or, worse, plus 2 minus 3. Then it's plus 3 minus 2. You're okay with that, but if I change it around to minus 2 plus 3, if you stack them like this, then plus plus, easy peasy. If this was minus, 3 minus 2, 1. It doesn't seem like a big difference when you're only dealing with two of them. But later on in this year, when I show you what trinomial times a trinomial looks like, you're going to be thankful that you've seen this. Okay? I don't care if you use it. Couldn't care less. You're welcome to write your trinomials 9 terms long and then try to collect your like terms. I find that to be easier. Totally up to you. Okay? So, look what we have here. That exact situation. Go ahead and do that with algebra, not a picture. Go. If it helps to draw the arrows, draw the arrows. I will not fault you for it. Everybody should have this answer now. Now, I am going to do something, because I like to keep you on your toes. I am going to do something that, again, some of you probably may have seen, but I'm going to do it anyway, because it actually helps us further down the road. It is not something that you need to use for this. It is something that will help me teach you later. So I'm going to show you anyway. Please notice, is there a connection between positive 3, negative 1, and positive 4? No, they're all integers, but is there a connection mathematically between them? What is it, Harsh? Negative 1 plus 4 equals 3. Negative 1, 4, 3. Now, I want you to go back up to right here. Is there a connection between positive 3, positive 2, and 5? 2 plus 3 is 5. It has now happened twice in math. How often will it happen? Always. So, when you are faced with x plus a times x plus b, you know, and please notice it only works when there's an x there, or an m or a p, has to be a single letter. This is going to be x squared. This is going to be a plus b times x. Everybody see that? Does everybody see that? Okay. Now, is there a connection between -1, +4, and -4? What is it? -1 times 4 is -4. Look at the previous example. Is there a connection between 2, 3, and 6? What is it? 2 times 3 is 6. It has now happened twice in math. How often will it happen? Always. When? When I have a single variable at the front. So the third term is going to be plus a times b. And that will work always as long as you are starting with a single letter. Let's see if you understand. What is p plus 3 times p plus 5 in about 3 seconds? No drawing. P squared plus, which is 8p plus 15. Good. What is q minus 2? Q plus 4. Q squared plus 2q minus 8. What is m minus 2 and m minus 6? M squared minus 8m plus 12. Everybody good? That trick only works with single variables. Okay? All right, now listen please. Your job for today, and it is all I am getting you to do for today because you have a test tomorrow, is page 122, 123, and 124. Now look please. 122 and 123 are practice, aren't they? Okay. Tomorrow, while you are writing your test, I'm going to make those keys. Okay? I'll be drawing. I won't be talking, but I'll be writing it all out, and I will put it on YouTube. You use that to check 122 and 123. Because on Tuesday, we are going to mark 124 as an assignment. Okay? So by Tuesday, all of it needs to be done, but by Friday evening, you will have the answers to 122 and 123, so before you go on to 124, you'll know if you're doing it right or not. Okay? Everybody understand? Now, are you welcome to go all the way to the end of 124 now? Sure you are. I don't care. But remember, you have a test tomorrow. That test probably won't take the whole block, and you might want something to do afterwards. Okay? Any questions? No? Excellencio. Go.